traditionally, most organizations were doing digital twin we used to do 2D designs, and then we shifted to do 3D modeling, and so I got somewhat of a digital twin of what the product was, representation-wise. But from a manufacturing standpoint, now being able to fully create a digital twin of the entire manufacturing process and being able to simulate that well before you even get a plant is amazing. And what Siemens is doing around taking that manufacturing digital twin and using that from a simulation for ongoing, every time I have a new order, what's going to happen as it goes through that process is what's saving most companies just a dramatic amount of inventory and churn and rework because they're making sure that they have everything in right place, right time to be most efficient, most effective.
We did a lot of modeling on a previous project for engine modeling and that kind of stuff, and we developed a digital twin that basically we could run the engine on a computer just like it was running in the test cell. So developing that digital twin was something we've been doing in the last 6 or 7 years with simulation and modeling. So taking it to a design level here using the integration is a big advantage.
It takes you to a higher level of science, to be quite honest. As an engineer, when I see an engineer say, oh, that didn't work, let's change it here and let's test it, it just drives me crazy. Because if we're at the point where we're building and testing, that's not very scientific. That's a trade, that's a skill, but it's not engineering. So engineering is you analyze it, you identify what you expect the outcome to be, then you simulate it with a digital twin. If you don't get what you want, then you modify your design before you build it. There's no time for building anything anymore. So we have to use the science to be where we need to be.